Welcome back to Machinist Made. Today we're going to go over how I would machine the Titan 8M. So the first thing we're going to do is, like always, is start with a setup. Once we're in the setup tab, we're going to go over to our work coordinate systems orientation. We're going to go from model orientation to ZX. And I'm just going to click the top of the part. Once I've got that done, I'm going to select a machine. Now, I've got a machine in my recent because this is the machine that I always use for demonstration purposes. But once you have that machine selected, it's going to ask you to download. Once you get that machine downloaded, it's going to prompt you to save that machine in your file location, and then it's going to bring up, you'll be able to see Machine Vf-2 right here. We're now going to work over into our stock tab. We're going to go to fixed size box instead of relative. It's telling me that I need 5.5 inches of material by 2 inch by 1 inch. The only thing I want to verify is make sure I got material on the ends. Once I've done that, I will then go down here to model position, offset from top, and I will change that to 20 thousandths. If you've watched my other videos, this is pretty much the same thing I do for every single part. That 20 thousandths represents 20 thousandths worth of material on the very tippy top of the part. Now the next thing I'm going to do is go to my post processes right here. I'm going to change this program to 8008, and I'm going to call it Titan 8M. Then my format is going to be standard. Standard is your G54, G55, G56, G57, G58, and G59. And then extended is what we call on the Haas our P series, so G154, P1 through P99. So I'm going to stick with my standard G54 because I don't need anything else. And I will simply click OK. Once you click OK, if you imported the machine model, it will bring the machine model in. Now this is not the complete model. You'll have to go import a vise and everything else into your machine setup. But for the day's demonstration, I am just going to turn that machine off and continue on with the CAM process of this part. First thing that we're going to do is we're going to face the part off. So up in the facing tab, the tool that we're going to use is a 2-inch face mill that is located under the Fusion 360 library tab under milling tools. 2-inch face mill is the only one that Fusion uses. Mash select, and then we're going to change the spindle speed to 3500 RPM and a cutting feed rate of 40 inches a minute. Now 40 inches a minute on the face mill that I have at 3500 RPM will give me an almost mirror finish. Your mileage may vary depending on the kind of face mill that you have. Under the geometry tab, there's nothing I have to do. Same thing for most of these, except today we're going to talk about the heights tab a little bit more than we have in the past. So the way Fusion defaults is it'll give you a clearance and it'll give you a retract point. I don't like this. I like my tool to come down and knowing it's only going to be 1 or 200 thousandths above the part. So on my retract plane, I will change this to model top, and I will change this to 200 thousandths. I will also change my retract height to 100 thousandths. And then I will also change my feed height to 100 thousandths. This tightens everything up. Now I do realize most people don't like this approach, but I do. So after I do that, the only other thing I have to do is basically just click OK. The machine control will take over and it will face the part off. Now the next thing that I'm going to do is the adaptive clearing. This is going to get rid of all of the excess material around the outside of the part. So up under adaptive clearing right here, I'm going to go in. I'm going to use a 3/8 end mill to do all of my milling work. This end mill again can be found under the Fusion 360 library, milling tools, flat end mill, and then that tool is located right here. I will change my feeds and speeds to aluminum roughing because this part will be made out of aluminum in the end, and I will be roughing it out currently. So I'm going to mash select. I'm going to go into my geometry and I'm going to select the bottom of the part. Once I've done that, I'm going to click on passes and I am going to change some of these load settings. I'm going to change this to 75 thousandths. And then I am going to leave my material at 1 thousandths radially and axially. I'm going to turn smoothing on. I'm going to change that smoothing value to 1 thousandths. And feed optimization, I'm just going to turn it on and let it use the default settings. Now the next thing I'm going to do is simply click OK. And there is my toolpath for the outside of my part. Now for the holes on the inside, I could do the same thing and let the tool helix in, but I can make this part a faster way by pre-drilling the hole. So I'm going to select a drill. The tool that I'm going to use is a 1/2 inch drill. So if you go under drilling, hole making tools inch, diameter, and change equal to 0.5 and hit enter, you'll bring up a 1/2 inch drill. Now again, I'm going to be doing aluminum, so I'm going to do aluminum drilling. I'm going to mash select, and then under my geometry tab, I'm going to select both of the hole wall diameters. Now this is going to create a problem, and we'll have to change some more things again in the heights tab. For one, the drill is not going all the way through, and it's feeding into the part. Little information about Fusion 360. Green is a feed color, yellow is a rapid color. So we don't want that drill to rapid into the part, so we're going to go over into the heights tab. We're going to change our retract from model top 200 thousandths, retract, model top 100 thousandths, and then feed height to 100 thousandths. Then also on the top height, instead of hole top, we want to go to model top. And then on bottom height, we're going to click drill through, and I'm going to add an additional 100 thousandths. My drills are 118, but again, I'm drilling aluminum. And if you've ever drilled aluminum on a CNC, you'll realize that at the bottom of the hole, it wants to push the material. It's called material deformation. It's pushing the material out of the way as it's cutting it. It's cutting as much as it is rubbing in some cases. So I want to make sure I'm punching that hole all the way through. Once I've done that, I simply just click OK. Fusion will go through its thinking process, and now we have a perfectly drilled hole. Now I can come back with another adaptive clearing cycle. I can go into geometry and select the bottom of those holes. I can then go over to passes, change my optimum load to that 75 thousandths as before. Again, 10 thousandths axial and radially. Turn smoothing back on at the 1 thousandths I typically do, and feed optimization. And if you do anything wrong in Fusion, it'll gladly point it out and highlight it red. Instead of 750 thousandths, I wanted 75 thousandths. Also in the linking tab, if we didn't pre-drill the hole, we would have to either helix or ramp in, because you don't plunge with end mills. You're not supposed to plunge with end mills anyway. So instead of helix, I'm going to do plunge. Now, I don't want to rapid into the hole. Just in case something happens, I want a little bit of time to stop the machine. You know, if a drill breaks off or something and I can't quite get to the machine quick enough. So I'm going to change it to plunge, and then I'm simply going to click OK. Now Fusion 360 is smart enough to realize there's a hole in that part, and you'll see right here we have that yellow line indicating it's plunging down, and then the tool is feeding out. So at this point, I need to finish the part. So I will go into 2D contour. I'm going to use the same tool in my setup. I would advise you using a different tool. You don't want your roughing and your finishing tool to be the same in case your roughing tool becomes damaged in the material mover process. So I'm going to select the outside and the inside of these circles. I'm just going to contour everything at one time. I will go back and change my tool by right-clicking on it or clicking on it left hand. Either one will work. And I will change this to brass finishing because I want a nice smooth surface. So I'm going to finish it a little bit slower. Mash select. Everything will automatically change. Again, I'm going to go into my heights tab, and I'm going to change this to model top 200 thousandths, retract 100 thousandths, and feed 100 thousandths. Then I can simply just click OK. Not too much here to do. Now you will see how that tool decided it wasn't going to clean it all up. So to change that, and also I want to clean this up out here a little bit more as well, we can right click, go back into edit, go into passes, turn roughing passes on, maximum step over 300 thousandths, and do. Now that tool comes in and it actually cleans everything up the way it was supposed to. So now at this point, the only thing I have left to do is to cut this undercut in. So if I click off, you'll be able to see this undercut. We call this a keyway groove, snap ring groove, and then we have to put some chamfers on it. So the first thing I'm going to do is do the chamfers because that's the easiest, and we've done this before. So we're going to go in the 2D contour. The tool that I'm going to use, again, is found in the Fusion 360 library. Milling tools, engraving and chamfer milling, and this 1/2" tool right here. Mash select, and then we can go into our geometry tab and select the bottom of our chamfers. This is the easiest way I have found to do chamfers in Fusion 360. Over into our passes tab, the only thing we have to do is tell it a tip offset, so that way we're not running on the center of the tool. I'm going to use 50 thousandths in this instance. And then I'm going to simply click OK. Then that puts our nice pretty chamfers on our part. Now the last thing to do again is this undercut or keyway groove. Now you can go into Fusion under contour, and I believe Fusion may have some keyway tools in here. They're calling it slot mill, and they do. They have 2 of them. So now I don't know if these tools meet what we need. So I'm going to first go to this tool, right click, view tool, and I'm going to look at the specs of the cutter. So the flute or shoulder length flute length is 31 thousandths. This cutter will not work. However, if you take a brief moment and go online, you can find a cutter that will. In this instance, I'm on the MSC website because it's one of the largest metalworking websites that you can go to. And I have found a Harvey Tool Woodruff key seat cutter, and it is a 1/2" shank and 125 thousandths width. What this means is the tip of this tool that actually does the business end is 1/8 of an inch. So this is the cutter that I'm going to model mine off of. So going back into Fusion 360, this one already has a 1/2" shank. It's already plenty long enough. So what I'm going to do is select that tool, go back into select right here. Now I can right click and edit that tool. You have to pull the tool out of the library before you can edit it. I'll go into the cutter, and this is where I'll make my changes. So my shoulder length and flute length needs to be 125 on the flute, and shoulder length I'm going to change to 1 inch. Now that's obviously wrong, so I'm going to change that to 125 thousandths. And now we have a key seat cutter that is modeled very closely. The only thing I'm going to do is go back and double check to make sure everything is right, and it appears to be. So I'm going to click accept, select, and then under my geometry tab I am going to select the bottom inside part of that groove. Then I'm going to go into passes. I'm going to do roughing passes because plunging a cutter that deep into aluminum is not that good of an idea, especially on a Woodruff cutter. Aluminum can be kind of gaudy, so I'm going to do a 50 thousandths step over. I'm at least going to do 1. I'm going to go into linking and make sure my lead in and lead out is turned on. And then I'm simply going to select OK. Now you can see our toolpath is there. And if we simulate just that toolpath, we can see that cutter is acting properly and entering into the cut and making its way around. It's going to do 2 passes. One thing you always want to check is to make sure that when your cutter is at full depth, it is not hitting. Now in this instance, it's really close, but there is clearance there between the shaft of the cutter and the wall of the part. The shavings on a key seat cutter come out the back end, so you shouldn't have a problem. Well, once I've done that, this part is completed, except I am going to make one minor change, and I'm going to drag my drill above because order of operations. We're going to face, drill, and then do all of the contouring and finishing, and I will do my chamfers last. Make sure that's in the right spot. So we have tool 5, which is my face mill, tool 7, which is my drill, and tool 6 is doing all of my machining for material removal and finishing. Then I've got my key seat cutter and my deburring tool. So that's basically going to conclude it for this part. The only new thing we really went over was this operation right here. If you've got any questions, comments, concerns, please feel free to leave them down in the comment section. I hope you like and subscribe so you can come back here and get more informational content about Fusion 360 and a variety of parts. You can check out my channel. I've got a whole host of tutorials on how to make multiple parts. Hope to see you back.